What if I told you that you could help save the world simply by eating more fish tacos? It's true. We are at the cusp of a global food crisis. The world population is growing, but land available to farm is decreasing. We lose a football field's worth of fertile soil every 5 seconds. So, how do we produce more food using fewer resources and less land? Enter the Nile tilapia. It's not just perfect for fish tacos. It's a resilient, fast-growing herbivorous fish that feeds low on the food chain, making it a sustainable source of food. Tilapias are 8 times more efficient than cows at converting the food we give them into muscle growth. You might be thinking, okay, I get it now. If I swap my burgers for fish tacos, I can help save the world. Well, that's a start, but the increasing demand for food, coupled with the negative effects of climate change, require greater efficiency. We'll really need to stretch our resources to provide enough food for all. This is where my research comes in. I'm working on ways to improve growth in tilapia to reach market size faster using fewer resources. To do this, we look at the muscle tissue. Proteins in the muscle are continuously being synthesized and degraded in a process called protein turnover. To understand turnover events and what's regulating them, I'm using RNA sequencing to look at gene expression. Let me walk you through a metaphor on how these genes are classified and what they do. We can compare the types of genes to members of a team. Different members have different roles. Let's start with the player's mRNA. We can clearly see each player and identify what they do. But that's not the whole team. Imagine microRNAs and lincRNAs as all the different coaches on the team. They don't play on the field, but they do determine tactics and have control over the players indirectly. Not much is known about the coaches, so I use sequencing data to identify them and their interactions to predict their influence on turnover events. I've narrowed it down to a few candidates for head coach, and these genes may serve as markers to help us select the best fish in breeding programs for tilapia and possibly other fish species. This will allow us to produce more food using less land, saving the world one taco at a time.